Friday, December 19, 2025, opened with a cascade of scientific developments that together painted a vivid picture of how dynamic, fragile, and astonishing our universe and our understanding of it continue to be. From the vast scales of interstellar space to the deep time of human evolution and the immediate environmental consequences of modern technology. As Comet 3 I/Atlas quietly slipped away from Earth after making its closest approach the previous night, reminding astronomers and casual skywatchers alike of how fleeting such cosmic encounters can be, especially when dealing with fast-moving visitors whose trajectories carry them briefly into humanity's observational reach before they disappear back into the darkness of the solar system. Even as scientists rush to analyze the last available data, images, and spectral readings collected during its flyby in hopes of learning more about its composition, origin, and behavior, while at the same time attention was drawn closer to home by reports of a Starlink satellite tumbling uncontrollably through space after shattering in orbit, an incident that once again raised concerns about the growing congestion in Earth's orbital environment and the long-term risks posed by space debris, especially as thousands of satellites are launched each year to meet global demand for connectivity, increasing the probability that collisions, fragmentations, and cascading debris events could threaten both active spacecraft and future missions. Alongside these space-focused headlines came a sobering reminder of the environmental cost of technological progress on Earth, as a new study claimed that AI systems in 2025 had a carbon footprint comparable to that of New York City and consumed water in quantities similar to the annual global consumption of bottled water, an assertion that has reignited debates about the sustainability of large-scale computation, data centers, and energy-hungry machine learning models at a time when artificial intelligence is rapidly embedding itself into nearly every sector of society, from research and healthcare to entertainment and defense, forcing scientists, policymakers, and technologists to confront the uncomfortable reality that digital innovation is not immaterial, but deeply entangled with physical resources, energy infrastructure, and environmental trade-offs. Against this backdrop of rapid change and occasional disruption, the return of the Science News blog after a brief technical hiatus was framed as a welcome moment of continuity, reconnecting science fans with a steady rhythm of discovery and inquiry that persists even when platforms falter, and setting the stage for a deeper dive into one of the most enduring and contentious questions in science: human origins. This week's coverage began with renewed attention on Littlefoot, a near-complete Australopithecus skeleton discovered in South Africa and first unveiled to the public in 2017, which remains the most complete ancient hominin skeleton ever found and continues to challenge researchers attempting to place it precisely on the human family tree, a task complicated by the fragmentary nature of most fossil evidence and the subtle anatomical differences that can separate species, populations, or even individual variation within a species. For years, Littlefoot has occupied an uneasy position in paleoanthropology, with some researchers arguing that its unique combination of traits warrants classification as a previously unknown species, proposing the name Australopithecus prometheus, while others countered that this name itself is problematic, having originally been assigned to a different South African fossil discovered in 1948 before falling out of favor when that specimen was reclassified as Australopithecus africanus, raising concerns about taxonomic recycling and historical confusion, and still others suggesting that Littlefoot might simply represent an unusually well-preserved or anatomically distinctive example of A. africanus, rather than something entirely new. The debate has now been sharpened by a study published last month in the American Journal of Biological Anthropology, in which the research team behind the new analysis argues that neither Australopithecus prometheus nor Australopithecus africanus adequately captures the anatomical reality of Littlefoot, pointing to specific skeletal features that they believe set it apart from known species and suggest a more complex evolutionary landscape in southern Africa than previously assumed, where multiple hominin lineages may have coexisted, diverged, and adapted to different ecological niches over millions of years. As with many claims in paleoanthropology, these conclusions are unlikely to be universally accepted without scrutiny, replication, and vigorous debate, and the classification of human fossils has long been a contested arena where interpretations evolve as new evidence, methods, and perspectives emerge, making it all but certain that other anthropologists will weigh in with alternative analyses, critiques, or support in the coming months, potentially reshaping how Littlefoot is understood and how it fits into the broader narrative of human evolution. While these deep-time questions occupied researchers and readers alike, the weekend also offered a more immediate and accessible spectacle in the night sky, as the Geminid meteor shower reached its peak on Saturday night and Sunday morning under near-moonless conditions that provided ideal visibility for anyone willing to brave the cold, producing streak after streak of light as bits of debris burned up in Earth's atmosphere and reaffirming the Geminid's reputation as the most prolific meteor shower of the year. Although the shower had been active since December 4th, this peak window represented the best opportunity to witness the highest concentration of meteors, a chance that many observers seized with cameras and tripods, while others, constrained by schedules, weather, or simple reluctance to endure freezing temperatures, missed the moment and were left to take comfort in the fact that the Geminids would remain active until December 20th, offering a few more nights for latecomers to step outside and look up. Plans to assemble a gallery of standout images from the peak underscored how such celestial events now live on not only in personal memory, but in shared digital archives, where photographs and time-lapse videos allow the experience to be revisited and extended far beyond the fleeting seconds each meteor spends crossing the sky. And for those seeking a deeper understanding of the phenomenon, resources like the 2025 Geminids Meteor Shower Guide by skywatching expert Jamie Carter provided context, tips, and scientific explanation, tying together the mechanics of cometary debris streams, orbital dynamics, and observational strategy. Taken together, the day's stories illustrated the remarkable breadth of modern science reporting, where discoveries about ancient ancestors, warnings about orbital debris and environmental costs, and moments of quiet wonder under a dark sky coexist in a single narrative, each reminding us in different ways that humanity's past, present, and future are inseparably linked to the wider universe we inhabit. Until December 20th, offering a few more nights for latecomers to step outside and look up. Plans to assemble a gallery of standout images from the peak underscored how such celestial events now live on not only in personal memory, but in shared digital archives, where photographs and time-lapse videos allow the experience to be revisited and extended far beyond the fleeting seconds each meteor spends crossing the sky. And for those seeking a deeper understanding of the phenomenon, resources like the 2025 Geminids Meteor Shower Guide by skywatching expert Jamie Carter provided context, tips, and scientific explanation, tying together the mechanics of cometary debris streams, orbital dynamics, and observational strategy. Taken together, the day's stories illustrated the remarkable breadth of modern science reporting, where discoveries about ancient ancestors, warnings about orbital debris and environmental costs, and moments of quiet wonder under a dark sky coexist in a single narrative, each reminding us in different ways that humanity's past, present, and future are inseparably linked to the wider universe we inhabit.